In this lecture, we'll talk about some key concepts related to game audio. Just like with game graphics, you may be familiar with some of these concepts. However, I want to cover them to fill in any gaps in your knowledge so that we can communicate effectively as we move forward. When I speak, my voice interrupts the air and creates sound waves. On the other end, your ear receives these sound waves, creating small vibrations that are transmitted as information into your brain, which you can interpret as sound and hopefully intelligible speech. So the question becomes, how do we capture these sound waves, place them into our games, and then play them back at appropriate times so our players can hear them? We use the graphics display model to speak about game graphics. Well, let's modify this model slightly to reflect audio playback. Instead of the display, we'll have a speaker as our hardware component, with the rest of the model remaining pretty much the same. Let's start by talking about the hardware or speaker layer. In terms of the speaker, I'll not talk too much about the technical details of the hardware, other than to say the speaker is what turns our digital data back into analog sound waves. That is, the speaker vibrates and disrupts the air, creating sound waves that our ears or the ears of our players hear. The type of speaker and the quality of speaker have an impact on how sound is experienced in our games. The speakers integrated into a laptop computer will not typically create the same experience as a two-speaker system with subwoofer, or a 7.1 surround system for that matter. And of course, headphones are another form of a speaker that are often used in gaming. Unity 3D is able to create 3D positional audio on a variety of speaker systems, including headphones, to create an immersive audio experience in your games. Now let's talk a little bit about the model layer. The model layer defines how the audio is represented internally within the game or software. There are two primary models: digitized audio and synthesized sound. I'm going to focus mostly on digitized audio in this lecture. The process of turning the analog or continuous sound wave into digital data is called sampling. What we do is we sample the sound several times a second. This is called the sample rate and is typically measured in hertz or samples per second. The digital sample is an approximation of the original analog sound wave. The more times per second we sample the sound wave, the better the approximation. Or in audio terminology, the higher the fidelity of the sound. Typically, music is sampled at speeds of 44.1 kilohertz or 44,100 times per second. The other component in sampling is how much data are we storing per sample, or what is the sample size. We typically store 8 bits, 16 bits, or 32 bits of information per sample. The larger the sample size, the better the resolution or signal-to-noise ratio, or in audio terminology, the more dynamic the sound is. Lastly, we may sample multiple sound waves coming from different sources and then mix them together to create one or more tracks of information. Of course, one track is typically referred to as mono audio, while 2 tracks is stereo, and we can have many more tracks in a multi-track recording. Game assets typically have a sample rate of at least 44.1 kilohertz, a sample size of at least 16 bits, and are either mono or stereo depending on their use in the game. Let's conclude by talking a bit about the audio file formats. There are a number of proprietary audio programs such as Adobe Audition or Audacity that have their own file formats that support all the features of the software. No matter what audio tool you use, you typically can save or export to a WAV, AIFF, MP3, or OGG file, which are file formats that Unity 3D supports directly for importing. When saving to one of these file formats, you typically need to specify the sample rate, the sample size, and the number of tracks. In the next video, we'll discuss a bit about creating game audio.